everyone, welcome back to my math teaching channel online today. So today is a beautiful day. It's very sunshine when I look out the window and it make my mood, it become very happy. So I'm happy to show you the lesson on the derivative, how to use it and solve the problem. Now I have one geometry problem on the board. So let's go right into it and see how we're going to solve this problem. So let me read this problem to you one time. A water trough is 10 meters long. So from here to here, this is the shape of the trough, 10 meters long. So from here to here is 10 meters. And the cross section has the shape of an isosceles triangle. So this is the isosceles triangle. That is 1 meter across at the top. So at the top from here to here is 1 meter across and is 50 centimeter height. So this trough have a height of 50 centimeter. The trough is being filled with the water. So we pour the water into the trough at a rate of 0.4 meter cube per minute. So the rate of the water changing for 0.4 meter cube per minute. So this is the rise of the water level, keep changing. How fast will the water level rise when the water is 40 centimeter deep? Okay, so the question give us some information and ask one question. Usually when I am doing the word problem, what I do is I always write out the short form in short form, what give information they give us, what data they tell us, and what their question. Usually in on word problem, that's what I did. So let's get right into in here. So I'm going to say given what? This information, dV, this is the volume, right? dV over dt equals 0.4 meter cube per minute. What else do they tell us? They say the length of the trough is 10 meters. What else they tell us? The base of the triangle, right? The base of triangle equals 1 meter. And the question, and what else? The height, and I call the height 1. Height 1 is the height of the trough, right? Because we have two heights here, different, right? The height 1 is talking about the height of the trough, but the height here is the height of the water, level rising, right? So the height 1 is 50 centimeter. Now, I don't like the different unit, right? Because we're talking about meter cube and 10 meter long, and here we have centimeter. So I'm going to change this become meter as well. So 50 centimeter equals 0.5 meter. So we know the height 1 is 0.5 meter. What else do we know? The base is 1 meter, and that's in unit meter, so that's 5. So now what is they ask for? They ask to find dH over dt, which is how fast the water level rise. And we're talking about this H, the H of the water, not this H. This H is fixed, right? This H is a variable changing. And the question asks for that. So now we know all the information we know this question asks for. We're going to solve this problem. And how do we solve this problem? So let me show you the full board. So to find this, we're going to have to put in the function of one kind of volume. And we want to find the volume of water, right? we don't want to find the volume of the prism. However, we have to base on the volume of prism formula to find the volume of water. So the formula of the triangular prism to find the volume is equal the area of the triangle, which is the base. If you stand this up, right, you will have a base of triangle, and this is the height or the length of the prism, right? So any object, to find the volume, we find the cross-section area of the object. And in here, our cross-section of object is a triangle. So the volume will be equal the area of triangle times with the length of the prism, right? Now, but we also know that we don't want to find the area of the full triangle, the big green triangle here, but we want to find the small triangle, the blue triangle here, right? Because that is the triangle of the water, not triangle of the prism, right? So we want to find the triangle of the blue triangle here, right? Small blue triangle here. And we use the blue triangle here, area of that blue triangle. So I'm going to put the blue here, right? Time with the length. So now after we have a function, we're going to put any information in here. So let's see how we got. So volume of the water, W, right? Extend water is W, okay? Equal the area of the triangle, and the formula for area of triangle is 1/2 base, right? Time height and time with the length. So now we're gonna substitute one more time. So equal 1/2. And remember this base is the base of the small triangle of this one here, right? This base here. And remember this base here is changing. Whatever the height is, right? Depend on this height rising, then this base is changing. So I'm going to call the y of the water here, and I'm going to name is x variable. So before we do that, let's say let x be, and not let x, let 2x, right, be the base of the water. The base of the water triangle, right? So now I'm going to substitute the base here is by 2x time with height and time with length. I'm going to substitute length by 10 meters. Because I know this is 10 meters, right? It's a fixed variable. Only this one is unknown and the x is also unknown. Now we have the function, we can take derivative now, we solve for it. However, we have two variables, x and h, right? So actually three variables, v, x, h in here. So usually it's hard to solve the equation with two variables. So I'm going to change, what I try to do is I want to change the x in terms of h. Let's see how we're going to do that. How are you going to change one variable by the other variable? Because we want to keep one variable only. We don't want to put x and h together, right? Two variables, too complicated. So I'm going to change the x in terms of h. And how do I do that? I'm going to look at this triangle here, right? So what I do, I'm going to relate this ratio so that's why I pick this triangle here, I draw down here so we can manipulate with whatever it is, right? So by looking at the shape of one triangle, half of triangle here, I can relate it variable x with h. I say x over 0.5. Now I know this is from here to here 1 meter. It's given. So half of it is 0.5 meter. So X over 0.5 will be equal H, right? This one from here to here over the full length, right? So look at the ratio, the way you will pair small length with a big length here. Small height with the big height here, right? So this over this equal this over this. So equal 0.5. Now we do cross multiply. We have 0.5 x equals 0.5 h. So what does it tell us? It tells us that the x here equals the h in this case, right? The x length here equals the h length here. So this x equals this h. So now we know x equals h already based on this ratio. We can substitute x in terms of h. So go back here, I'm going to say 1/2 times with 2. X now become h, right? Because I know they equal, times with h times with 10. So let's simplify one more. We have 2 here, cancel with 2 here. The h here times with the h here, and times with 10. So I'm going to put the 10 first. And h power 1 times h power 1 is h power 2. So this is our function. We want to take the derivative of this function. So let's do the derivative of this function. Now you also know that if we want to take derivative, we have the dv over the dv over dt equal dv over dh times with dh over dt, right? That is by the chain rule. So we know the chain rule, dv over dt equal dv over dh times with dh over dt. So we have to figure out this one. Do we have to figure out? Yes, it means we have to take derivative of volume respect to h. So let's take derivative of this. So dv over dh equal dv over dh equal 2 times 10 is 20, 20h. So now we know dv over dh. So let's substitute anything we know into this equation. So we have dv, we're going to take derivative that, dv over dt equal dv over dh times with dh over dt. Now let's substitute any value we know in here. We have dv over dt equals 0.4. That's a given information, right? Right here. Up top, right? This one. So now we're going to do this. So 0.4 equal dv over dh is 20h times with dh over dt. And this is the question we want to find out. So now if we divide both sides by 20 over h, we can cancel that, right? So divide by 20h will be equal dh over dt. So I'm going to make a little room here, okay? I don't know if you can see my handwriting on this side. Yes. So let's do that. So now we have 0 over 4, 0.4, sorry, divide by 20 and time with h. We know that the question asks for how fast will the water level rise when the water is 40 centimeter deep. And 40 centimeter deep equal, actually I'm missing this information, right? So the height of water equal 40 centimeter equal 0.4 meter. So we know that. So I'm going to substitute in here time with 0.4 equal dH over dt. And this number divide, you will get 0.0.5, and the unit is what? Meter. How fast is the water level rise? Meter over minute. And that is the answer of our dH over dt. So I hope you understand this, right? So let me summarize a little bit. So we have a water trough, right? We have a water trough, and they told us the length of the trough is 10 meters. The height of the trough is 1 meter. Have a cross section from here to here is 1 meter. And they asked how fast the height here is changing, the rate of change of the height changing. So we call it dH over dt when the height of it, when the water dry at that point is 0.4 meter height. So given the height of water when we pour in equals 0.4, what is the rate of change of it? That's the question. So now we have to solve this problem, we have to establish the meaningful function based on the problem. And our function in here is volume equal the area of a triangle, water, right? The blue triangle here, small triangle here, not the full triangle big, because we fill the water in. So the area here, just the area of the water. So will be 1/2 base times height, times with the length of the prism. So now we follow the base of the water is 2x, right? 2x, 1x, 2x, time with the height, time with 10. So now we cancel the 2 here with the 2 here, and we try to relate it, the x variable here, the x here, in terms of the h, so that we end up this equation only have one variable instead of two variables, x and h. And how do we do that? We go back to this triangle. We do a little ratio in here. We know that we can pair the x here, the wider of the water with the y of the prism, right? So from here to here is 0.5. So we pair x over 0.5 equal height over the full height. And the full height here is 0.5 meter. So now after we pair the ratio, we solve for x in terms of h, we get them equal. So now we know the equal, we substitute the x here by h, and we ended up with x squared. And now we do the derivative of this function, we get our answer down here. So I hope that we don't miss any, you don't miss any of my writing on the board. And you understand this problem very well. So this will, I think so far I have shown you how to solve the word problem for 4 of them already. So maybe the last one, I will do one more problem, and it's keep you, and help you to keep going with the application of derivative. We still have a lot of the, I think we still have 2 chapters to finish my introduction to calculus course. Just the first course. The second course will come after, but I'm thinking about maybe I do the pre-calculus 12 or geometry before I do the second calculus course. But this is the first one, and this is very intense as well. A lot of information, a lot of chapter, a lot of lesson. We still have 2 more chapters to go, which is extreme values. And Don't come up to my mind right now what the last chapter. But anyway, I hope that you enjoy my lesson, my teaching online, and I hope that you will give me a thumb up and like. That's I hope for, right? So thank you for watching and see you in the next video, the last video for application. I will upload the file of all the word problem. Some of them were similar with what I taught here, and some of them are different. And you will invent it to see how you can solve the problem in derivative. So thank you for watching. Bye for now.